Alright, welcome back to the final video in the BCPC3 solution set, or solution videos. And this is going to be to planes. So planes looked like a really scary problem. I'll go over it quickly because a lot of teams probably didn't even look at it too much. They just saw it look scary and then they got bored. So you love all types of planes. You love Cartesian planes, woodworking planes for planing, which is a real thing. Planes like the grassy planes, and even airplanes, the Minecraft biome planes. Yeah. But you don't like layovers. So the BCPC, Belarusian Carrying by Plane Company, is going to introduce a bunch of new flights, and they're going to hopefully reduce the number of layovers that are necessary to get between some pairs of airports. So there are N airports, and currently there are M flights. But they're going to add some new flights. In particular, they're going to add N new flights, and you can choose what the new flights are going to be in order to minimize layovers. And at the end, they're going to have N plus M flights total. So they're going to add the new ones, and then they'll have some more at the end. So at the end, they want it so that after you add the N flights, you can travel between any pair of airports between some number of flights. Also, they want to minimize the number of flights you have to take between whatever number you need to take the most flights for. So here's some example. So in this, say there are four airports, and initially you only have the two flights between 1 and 2 and 1 and 3. So since we're adding 4 new edges, we can add an edge between 1 and 4, 2 and 3, 2 and 4, and 3 and 4. So those can be the 4 flights we add. And once we've added this, it's possible to get from any airport to any other airport in just 1 flight. That's why the answer here is 1. In this example, we have a bunch of flights that go between 1 and 3, and we can't add all of these, so we can't make everything distance 1 away, but it is possible to make everything distance 2 away. We can connect 2 to 1 and 4 to 1, and then we can connect 2 to 3 twice if we want. But even if we didn't connect these two, you can see that everything is still a maximum distance 2 away from each other. So if you want, you can pause the video now. The important thing is that N and M are both up to 10 to the 5th, which is kind of a high bound, so you can't do N squared. And also you can't brute force which flights you're going to add, because there are lots of possible flights of like which ones you're going to add. You can't try like all possible ways of adding new flights. That'll be way too slow. So if you want to pause the video and think about how you might do this, now would be a good time to do that. Otherwise, I'm going to assume you haven't paused the video, or you have and you thought about it and you want to see if your solution's right. So basically, one thing to notice is that the biggest the answer could ever be is 2. You'll never have an answer of 3. The answer is always 1 or 2. And the reason that's true is because you could connect, you have N new flights, right? You could use N minus 1 of those flights to connect every airport to airport 1. And if every airport's connected to airport 1, you can always use 1 flight to get to airport 1 and 1 flight to get to wherever you're going to. And if you're going to airport 1, you can obviously just go straight to airport 1. So the answer can always be 2. So now we don't have to worry about whether or which flights you're going to add. All we have to worry about is whether or not it's possible to make the answer 1. And if it isn't possible to make the answer 1, we know the answer is 2. So we can check to see if the answer is, well, the other thing is like, okay, if the answer is going to be 1, that means every pair of nodes has to have an edge between them. So in this example, that's true. In this example, that isn't true. And even if like we duplicated this edge, we probably wouldn't want to duplicate edges that we're adding if we can avoid it. But even if we didn't, we're still going to be missing either this edge or this edge. So, you know, it's not going to wind up working. So basically, we just want to know, if we don't duplicate any edges, will we have enough flights in order to make every node connected to every other node? The number of flights we're going to need is going to be equal to we have N nodes. Each node is going to be connected to N minus 1 flights, and then every edge is counted twice by doing that. So we're going to need N times N minus N over 2 total edges, and we're going to need those all to be unique. We can add N edges. So we need to know how many edges we'll have, or how many edges we currently have that are unique. And then of those, we can add N more, and we want to see, can we reach this magic number? And if we can, the answer is going to be 1. If we can't, the answer will be 2. We connect everything to some airport and do that. So let's make a scanner. and then we want to read in the number of nodes, number of edges. So what I can do is, well, yeah, let's do this. So we're gonna sort our edges, and then that way we don't need to do any fancy data structures. So we're gonna need to know from and to. We can pass those in the constructor. So we're going to sort the edges, we're going to sort them first by from. So if their froms are different, we'll sort them by froms. If their froms are the same, then we'll sort them by where they go to. So now we're going to make our edges. And we're going to, we can read these in 0 base, but it doesn't really matter. I'll just read them in 1 base. And then we're going to sort our, man, what is going on here? Just sort it, please. Okay. We're going to sort our edges. This will run in n log n time, so it's pretty nice there. And now, once we have that done, we can print, or we can check how many of them are unique. So if we do this, we know that edges that are the same are going to be like right next to each other in the array. So if we don't have any edges, then there are going to be 0 unique edges. If we have at least 1 edge, we're going to have that first edge. And now, if we have a pair that are different in the array, like an adjacent pair that are different, that will add 1 more unique edge. Equals 1, really. So if edges at I from is not equal to edges at I plus 1, or edges at I2 not equal to edges I plus 1 I2, then we have 1 more unique edge. So that's how many we have. We can add n more. And now, if unique is greater than or equal to n times -1 over 2, that means we can make everything 1 away. Otherwise, we can't. So if this is the case, we can just print 1. Otherwise, we have to print 0. So that's kind of the entire solution. It's a little interesting. It looks pretty scary at first because there are like all sorts of ways that you might want to add edges, and there are lots of choices, and it seems like a really hard problem. But really, it's that simple. Let me just make sure I don't have any bugs in my code, or any obvious bugs. Yep, so everything can be 1 away here. Here we've got lots of duplicate edges. Oh, interesting. Alright, well, print unique. Unique is 6. Huh. It should not be. It should be like 3. Oh, this is after adding n. Ah, yeah. Okay. So the other thing we have to do is we want to sort from and to. So because 3, 1 is the same as 1, 3. Cool. So, press Control. There you go. So now it seems great. Alright, cool. Yeah. So there's planes. Yeah, as I was saying, initially it looks like a really complicated problem because there are all sorts of choices you might make, and it's not clear which choices you should go about making first, or like which edges you should add. And then even if you do, it seems like you would want to do like a BFS from every node, and you can't even do that. But it turns out you don't need to. You can just make the observation. The answer can always be 2. So you just have to check if the answer is 1, and that's pretty simple to do, as we've seen. So yeah, I hope you enjoyed the contest. If you have any questions about particular problems, or you'd like to see some of your code, if you don't have it for whatever reason, I can get that for you. Feel free to email me at the email I presented in the 99 Red Balloons video. And hope to see you again if you come to other contests, hopefully by BCPC, or hopefully by us. So thanks for watching, and have a Merry Christmas.